All right, so I can apply the concept of dipole moments to the unique properties of water. A molecule that has a positive end and a negative end is said to have what in chemistry? It's said to have a dipole moment. Let's take it apart. Di means and pole, sides, two ends, two sides. Moment refers to, at simplifying it, at any moment you can see the molecule, it has two sides, it's a dipole moment. Okay? How is a dipole moment represented? It's represented with an arrow. So you have oxygen and hydrogen. Look up their electronegativity. Oxygen is 3.5. Hydrogens are 2.2. So you always draw an arrow from the less electronegative side to the more electronegative side, and you put a plus at the end. That tells you that this side, the side that the arrow is pointing toward, is the negative side, and the opposite side is the positive side. Hydrogen and fluorine. Hydrogen is 2.2, fluorine is 4.0. Draw the arrow toward fluorine, put a plus on the end. So that is how you show a dipole moment, with an arrow. There is another way. In Greek, the uppercase for D is the triangle. The lowercase is that kind of stylized letter D. So what you do is you put a little stylized letter D, negative, and a D positive. That's another way of showing that you have a dipole. Marina. Yes, thank you. Simon, you're checking out. What are some examples of molecules with dipole moments? All polar molecules. All polar molecules have dipole moments. See you, son. What characteristics does dipole moments give water? High surface tension, high melting point, high boiling point. It's called the universal solvent. So I'm going to show you a video. The video will give you all the answers you need for question number 9. 8, I've already given you all the answers you need for question number 8.
I need that.
It's in the copier over there.
Imagine an Earth without water, life without water. We find it everywhere, in the atmosphere and below our feet. 3/4 of the Earth's surface is covered by this essential liquid. It's a difficult thing to imagine life without water, because our own survival depends on it. In fact, water is vital to the existence of all forms of life on Earth. Water, or H2O, is an unusual compound with amazing properties. These unique properties are what make it so important to life. First of all, water happens to be the only substance on Earth that can be found naturally in all 3 states, as a solid, a liquid, and a gas. It is rare in that it actually expands as a solid, which is why ice can float. Pure water is essentially colorless, odorless, and tasteless.
Okay, so because water is able to orient itself in such a way that when it forms a solid, it has holes in it, there's plenty of space. What attribute does that give you? The fact that water is one of the most strangest compounds in all the universe, in that its solid is less dense than its liquid. Its solid is less dense than its liquid. I just gave you one of those.
Water has a neutral pH, which means it is neither acidic nor basic. Water has been called a universal solvent because it can dissolve many substances. Wherever water goes, either through the atmosphere, the earth, or through our bodies, it takes along valuable chemicals, minerals, and nutrients. This is one reason why water accounts for about 70% of the weight of a cell, which is the building block of life. Water has high specific heat, which means it absorbs a lot of heat before it changes temperature.
Stop right there.
This is why water makes a great coolant.
So water is very sticky. Okay? Because it's sticky, what two attributes does it give you? They just said it. It's not an attribute. High specific heat. That means it takes a lot of energy in order to separate it. What other incredible attribute does water have that allows it to function for life? They talked about it. Surface tension. Without what we did right here, we could not have done if it was any other substance but water. Water sticks to itself so much that it's able to be deflected like that.
This is also why oceans, lakes, and water vapor in the atmosphere help to regulate the Earth's temperature. Water molecules are sticky. They attract to each other, which is why water tends to float together, fall as raindrops, and bead up on the surface of a leaf. This property is the result of cohesion. To understand cohesion, let's imagine we're recreating a water molecule. A water molecule is made up of 2 hydrogen atoms and 1 oxygen atom. Because of the molecule's arrangement and the electronegativity difference between the hydrogen atoms and the oxygen atom, the molecule becomes polar. The oxygen atom has a negative charge, while the hydrogen atoms have a positive charge. Since we all know opposites attract, the oxygen atom will stick to a nearby hydrogen atom. The result is a strong bond. Surface tension is a result of cohesion and is the measure of how difficult it is to break the surface of a liquid. We can observe the high surface tension of water by watching this mosquito step onto its surface, or this insect as it struggles to free itself from a droplet. Surface tension is also what causes a water droplet to take a spherical shape. Water is the most cohesive of all non-metallic liquids. Adhesion is similar to cohesion, but refers to 2 different surfaces or molecules with an attraction to one another. This is why the droplet sticks to this leaf. Along with cohesion, adhesion is responsible for a phenomenon called capillary action. Capillary action is the force that pulls water upward against gravity through a narrow tube. This is an essential property for plants, which rely on capillary action to pull water from their roots up to their leaves. So it's pretty obvious that water is important stuff. Humans rely on it for personal consumption, as well as things like industry, energy production, and agriculture. But we sometimes have a tendency to use more than we need and pollute what's left. We need to make sure we keep it pure and plentiful.
All right. Did you get them all?
Yep.
I think it'd be, I guess, on A.
Okay. Well, too bad. Here we go. So, water is known as the universal solvent because it can dissolve. It has very strong positive and negative sides, and it can dissolve anything that is ionic or polar. The only thing that it cannot dissolve is nonpolar substances. Not because it's afraid of it, like biology said it was. They said, ooh, that's hydrophobic. It's not afraid of oil. It's simply that it's extremely cliquish. Water would rather stick to itself than have to deal with oil. And then, of course, water will form these bonds with itself. We're going to talk about this. This is called hydrogen bonding. All right?